Hello, everybody. If you have me at Heron, my name is Mr. Barron. If I don't have you at Riverside, you have Mr. Hanson. It's great to see and meet you all for the first time. And we are getting super excited about our second unit, which is all about making different types of prototypes. One of the types of prototypes going to be really important for us is something called a scale drawing. You might have heard the term blueprint before, pretty similar to that. And today we're really going to go through how to do one and how to translate that basic sketch that you made into something that actually is replicable and has a little bit of a plan. For today's homework, you're going to need a few of the materials that we gave you out to you um, in your picked up from school, the little engineering kits. You're going to need one sheet of graph paper. You'll need your cell phone because you're going to take some pictures and upload them at the end of this class. You will need a ruler. Yeah, that should say pencil. You need a pencil and a ruler that we gave you last time. Should be this clear ruler if you have one handy, and a Kleenex box, which is what we're going to work with today. If you don't have one, that's okay, but it might just be helpful to have it in front of you to visualize. So the question is, how do we actually make a drawing that makes sense? That has exact measurements on it. That shows exactly what the size of something should be and that we could use to actually build or plan something later on. To me, a Kleenex box is a really great place to start because it has a couple interesting shapes on it, and it's also it starts out as a rectangle, which I think is a good place for us to start for our little square drawing activity. So we're going to go ahead and dive into it, and as the first thing that we create is a sketch to show off how something works. So when I look at this Kleenex box, what I see, I'm just going to kind of draw it out simply for you. It won't be perfect. That's not the goal. Just to show off what it looks like. It's a little bit longer one way, a little bit longer one way than it is the other. So I'll start out by demonstrating that with this rectangle that I'm creating right now. Longer this way than it is the other way. There's kind of that big outside one. If you're looking at this thing from the top down, this is kind of the big outside square component that you see on it. There's a smaller rectangle, which is pretty close to the ends on one side, but a little bit further away on the other side. So, where do we start out? I think if we're going to make some sort of scale drawing, what we have to start out with is some basic measurements. That's what I'm going to go ahead and mark down that I took of this Kleenex box that I measured. You can check your own, see if it ends up being about the same, but this is what I found when I went and measured my Kleenex box. This long way down the side, about 6 inches, and I'm going to use the standard unit, a way of showing what an inch means, which is quotation marks after it. That's about 6 inches. While my top up here was about 4 inches wide. My top is about 4 inches wide. Okay? Now, the middle of this thing when I did a measure was about 5 inches down this middle. This long line on the inside is about 5 inches. And it's about 2 inches across the top. I was able to take these measurements and show off exactly about how big I think this thing is. Now, here's where it gets interesting. We can do a little mental math. You can either do this by measuring or with a little bit of mental math, but if this is 4 inches across, and this is 2 inches across the middle, the sum of these, this section between the two squares, the length of this side of the square, or the side of this rectangle, and this section between the two rectangles have to add up to be the same thing. So if this is 2 inches here, in order for us to get a good result for that, that means that I'm going to have a 1 inch gap on either side from where I start drawing it and from where I finish. Okay? And if this is going to be 5 inches, the long side of my inner rectangle, and the long side of the outer rectangle is 6 inches. That means that the gaps between the two of them and this 5 inches down the middle are going to have to add up to be 0.5 inches, or a half an inch each, because 0.5 plus 5 plus 0.5 is going to give us the 6 that matches up over there. We'll talk a little bit more about measuring these gaps in class on Thursday, but I'm going to start out with these measurements because it's going to help us make our drawing today, which is what we really need to be able to do. Now, I want to take this and I want to translate it to graph paper. And I've got this handy online graph paper I'm going to use to demonstrate this for you in front of me. If you got graph paper in the assignment or in the bag that was passed home over the course of our textbook pass out day on either of the 2 Wednesdays that we've had so far, and I want to see what you can do. If you don't have graph paper, you could either try to print some offline, or you can send us an email and let us know that it's going to be an issue for tonight. Okay? What you're submitting for your assignment tonight is the drawing that I'm about to make, in addition to one additional drawing that you're going to do on your own. Now, the graph paper you received has what's called a scale on it. A scale is our way of taking this measurement in real life and measuring it. Okay? The scale on the graph paper that you have, or at least the size of the squares that you have, is going to be 4 squares, an inch. In real life, if you count up the number of these squares, you'll find that if you add 1, 2, 3, or 4 of them, you'll get an inch. You can do that with your ruler right now if you find it helpful and want to check out to see that you believe me on that one. But the question is, how big do I actually want to make this thing? How do I take something that's big like this and get it to show up as the right size in the right proportions on a drawing? Our measurements are going to be a good place to start, but now we have to come up with this. If you have 4 squares to an inch, then that's going to tell us that each square is equal to 1/4 inch in real life. And the question that we have to ask ourselves is, how much do we want to change the size of this actual Kleenex box on our grid drawing? Some things, maybe like a Kleenex box, will actually be able to sketch out at real size, just about on here. But other things, we're going to need to be able to have to scale them down and make them a little bit smaller than they might be. So I actually want to practice that here right now. I want to practice doing that here today. Okay? I want to say today that while in real life, 1 square we've had 1 square is actually equal to 1/4 inch. For today, we're going to have 1 square represent a half an inch of our drawing. If each square represents more than it actually is, then the result that you have should be smaller than what the actual object is. So if our square of our drawing represents twice the actual size than the square takes up in real life, and what that's going to do is it's called a 2-to-1 scale. And that means that our drawing is half the size it actually is. Our drawing is going to be half the size that it actually is. Okay? So, in order to do this, we're going to need to do a little bit of math. Okay? And here's what I recommend you doing as you practice this for today. On one side of your graph paper, maybe take this right side over here. If you haven't already, you can go ahead and pause this video and just sketch out the drawing that I have on the screen right here. Not perfectly, just draw it. Don't make it perfect or anything. You don't have to worry about straight lines. Go ahead and write down your measurements. And then you're going to copy the scale changes that I'm making myself in order to do this, okay? Let's start with our biggest size over here. Our longest line is going to be 6 inches. Each square represents a half an inch of the actual Kleenex box. So that means that our 6 inches on this side is going to take up 12 squares. 12 squares times a half an inch per square is going to equal 6 inches. For this model, the math is pretty easy, and we can actually go ahead and kind of do this for all the sides that we have measured so far. As such, 4 inches in real life will take up 8 squares on our graph paper. 2 inches will take up 4 squares across the middle. 5 inches is going to take up 10 squares. 0.5 inches will be one measly little square because each square represents a half an inch, as we said for our scale drawing before. And 1 inch is going to be 2 squares on our graph paper piece. If you have questions on how I came up with the number of squares, that could be a great question to ask about at office hours, or feel free to go back and watch the video and see if you can figure it out. So now that we have our outline of how many squares each of these is going to take, we can actually go through and start writing on our graph paper now. You can do this in reality, but I'm going to do it on this online thing. You've got your graph paper and your ruler and your pencil handy in front of you. Okay? First things first. We said that our 6-inch side was going to be 12 squares. So the easiest way to do this, in my opinion, is to find a square on one side of your paper, the opposite side from where you drew your initial sketch. And you're going to go ahead and put your dot down. And if I were you, I'd put a little dot at the starting point, and then I would count down the number of squares that you need before actually drawing your line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here's my starting point. Here's my ending point. You've got a ruler out. You've dotted these 2 points right here. Go ahead and click it. Draw down 12. And bada bing, bada boom, you've got your first side of that Kleenex box. Okay? Now, if we go back to our drawing, we'll see if I can even have it open in your tab here. We said our short side of the Kleenex box is going to be 8 squares. So I'm going to start here. I'm going to count over 8. 1, 2, 3, 4, 5, 6, 7. There's my ending point. Drag over there. And I know that this thing is a rectangle, so I can go ahead and make these sides the same as the ones opposite. If you need a minute, go ahead and pause that video. Make sure you've got 12 squares down, 8 squares across, both on the 8 on both the top and bottom, 12 on both the left and right. You should have this nice even rectangle like that. Now, if we look back at our drawing, we have to draw our inner square now, and this is where things get a little bit trickier. Our inner square only exists on the inside, and we have to use these measurements that we had before to find its starting point. So if I look at my drawing, if I go 2 squares to the left, like I can see here of this starting top left corner, and 1 square down, I'll find that this dot is going to be my little starting point for the inner rectangle. So I've used those measurements to find where I'm going to draw my next line. The short side of this inner rectangle starts right here, and according to our measurements, it's only 4 squares. So I'll count over 1, 2, 3, 4. And now I'm going to go ahead and draw that in nice and straight. And from that starting angle that I found, it's 5 inches, so it's 10 squares going down. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And because it's a nice and convenient rectangle, I'll go 4 squares across here, just like I did on top. 10 down on the side. And bada bing, bada boom, I got a big, beautiful Kleenex box. And I've drawn it to that scale drawing size, like I said before, of a half an inch for each square, which means it's a 2 square scale. Go ahead and watch the next video for some brief instructions on how to do your homework tonight. Before this one ends, check to make sure your rectangle is about half the size of a Kleenex box you have on handy.